levels, we have a more complicated model of a concept in the system. For example, we can say every concept in the system is fluid in the sense that its meaning is determined is neither by reference to a object in the world or a definition, but by its experience relations with other things. With what reference and definition later we'll see, they will still be allowed, but they are special case or extreme case. In general, it's determined by relationship. And also the relationship, each of them is true to a degree. Not only that, meaning changes. For example, this idea is not really new, okay? The meaning of a concept is determined by the relation with other concepts. Yeah, many people have said that, but it's never practical. Why? Because in principle, every concept is related to all the other concepts, or a million of them, okay? If that's the case, when you use one of them, how can you take the other million into account? You can never do that. But in this system, it's not a problem because at the very beginning, we already assumed we don't have the time for that. Okay? So for example, when you mention bird, the system may only have the time to think about 5 relations about birds. And that 5 relations actually will determine what bird means to this system at this moment. And when situation change, then the next time you mention bird, the system may pick 3 other links. So that's a change in meaning. But it's not an arbitrary or random change. It's driven completely by history and experience or context. Okay. So it brings up many interesting things about how a concept changes meaning, where new concepts come from, and so on. So that's the first group, level 2 to 4. Level 5 and 6 is what we call higher order reasoning. Here, the idea basically comes from propositional logic and predicate logic. I have already said that they are bad, but there's some good idea we still want to use. Okay? So here, the first idea is we are going to treat a statement as a term. So we can have statements about statements. So that's where higher order reasoning comes. Okay? So between statements, we can also have a copular. Here, the 2 copular we use, one is the implication. It's kind of if, then, or what can be derived from what. The equivalence, which is if and only if. So we define them formally. We define compound statement. You see again, this is just from propositional logic. Negation, conjunction, disjunction, but they're defined differently. They're not defined by truth table anymore. Okay. Again, I don't have the time for detail, but it still shares some intuition. It's not completely different intuitively, but the formal definitions are different. And also, we also have conditional implication, conditional inference as implication. And also, we allow variable terms. It's kind of like universal, qualified variable, and existential variable, that kind of thing. We have something like that. We call them symbols, which can be used to represent other terms in the system. So with this 2 level, we say that this non-axiomatic logic actually can be used as a meta logic of arbitrary order logic. Because, for example, we are trying to do natural language processing by represent words, phrase, and sentence of another language, which can either be natural language or artificial language, as terms in this system. And we can also represent the inference rules of another logic as implication statements in this system. In this way, we can do natural language processing. Now we are, of course, only at the very beginning of those experiments, which is very different from the current NLP approach. And also, we can do mathematical reasoning. I have been saying that there's no absolute truth, and some people may ask me, how about 1 + 1 = 2? Is that absolutely true? Yeah, it's true in a subsystem, in number theory. It's a subsystem in this system. So the system as a whole is not axiomatic, is not mathematical theorem proving, but it can handle that kind of mathematical reasoning as a subsystem. Okay. Again, also I said truth value is not probability theory, but we can teach the system probability theory. Okay. But of course, it's not built in. It may learn it wrong, it may get it wrong. That's quite common, just like how we learn math. But it can be done. And finally, the top layer, the one that we work on in recent years, level 7, 8, and 9, that's about procedural reasoning. You see that previously, until level 6, what we have is a question answering system. Okay? But here, we begin to borrow ideas from logic programming. That is, we give some statement a procedural interpretation. Say, they not only represent a relationship, they represent something the system does. First, we introduce the concept of event. Those events are statements with temporal relations, that is, something is true in a certain moment. Okay? For example, the door was open, now is closed. Will be open again. Okay? So now you have tense, you have temporal order among your statements, especially you have sequential and parallel order. And then we define operations, which are events, but not just observed, but executed. For example, I can raise this table, this cup. Okay? But currently I cannot open the door, but I can explain or describe the opening of the door. And that thing is an event. This thing is an operation to me, but it's an event to you. You have no control, but you see the change. Okay? And if you control the change, that's operation. But since operations or events are nothing but special type of statements, we can use all the inference rules we covered to do reasoning about them. Okay? In that aspect, there's no difference. And also, this part is how we are going to handle sensory motor in this system. That is, we don't have anything built in, but we can allow something to be plugged into it. Say that we can send a robot a command as an operation. Say, do this, and do this means move the arm of the robot in a certain direction. Okay? The execution itself may be carried out outside the system, but the system will represent it and reasoning about it is operation. That's again, there are a lot of details we haven't really used it in a robot except in some primary experiments, but that's the plan. And finally, not finally, but at this level, we also introduce goals. Goals are also something can be reasoned about. Is an event to be realized. Say, I want the door to be open. Okay, that's my goal. Then I need to think about, okay, for that to happen, what can I do? Well, I can work there and open it, or I can ask some people I know in the audience to do it for me if they, actually do it, and then it will happen, and so on. Okay. So this part, clearly the idea comes from logic programming, but the major difference is in logic programming, everything is binary deduction. In this logic, clearly it's not that anymore. Okay, everything is to a degree, but the idea can still be used. That is, you can use reasoning to handle action. And finally, this is level 9, what we are working on. There's special type of operations, which is not like this or that. It's operation working within the system. That's what we call mental operation. Okay? For example, I already said, you accumulate evidence, then your confidence becomes higher and higher and higher. What if at a certain moment I told you that all the evidence you see are not real evidence, have been manipulated by someone else, that's actually fake, you actually know nothing at all about that thing. Here we have a mental operator, which you can tell yourself, okay, everything I have seen from that channel or everything I have heard from that guy doesn't count. Okay, you can do that kind of thing to yourself, to a degree, of course. So that's something we're working on right now. So this will allow the system to do what? It will allow the system to work as an agent in the sense that it's not just do question answering anymore. It can actually change the work on itself. It can achieve some goals by execute some operations. It can do cultural inference in a certain sense. Actually, last year, we had a paper presented talking about cultural inference in NARS. It can do prediction about the future. It can explain things happened according to what should have been the case in the past. Of course, there's no absolute truth. You know, prediction can be wrong, but that's your best guess according to record knowledge, blah, 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 blah. It can do planning. It can do skill acquisition. It can, in a sense, do self-programming, not in the sense of change its own source code. We don't think that's a good idea. Instead, by reorder its operations when trying to achieve a certain goal. Okay? To us, that's the meaningful interpretation of self-programming that can be done. And to a certain level, a certain extent, it have self-awareness and self-control. Like, for example, you can ask the system what you have just done, how you did that thing, what is good, what is bad. Well, of course, it doesn't really know that much, but a certain level, there's sensor and motors with respect to the inner environment as well as to the outside. Okay? It can do inference to both of them. So a certain level of self-control. And emotion and feeling, actually, they have a paper to be presented in Tuesday exactly on this topic, so I'm not going to talk about it today. So what makes this different from many other AGI systems is we have tried to unify everything. Okay? Those of you who are here this morning in Ben Gozal's talk, you may remember that Ben mentioned that. We have been arguing this for about 18 years. His approach is to integrate a lot of different things. My approach from the very beginning is try to do everything use one technique, which sounds crazy, but I hope I can convince you, okay, it's not that crazy. For example, this whole system is based on the same assumption of insufficient knowledge and resource. And they use a unified representation language for everything. And it has complete inferential power. In what sense, according to my definition, just basically the idea of completeness here means whatever the system can express can be derived by the system itself. Okay? Its expressing power equal to its inferential power. Meaning that in current AI system, very often there's some knowledge you can only build it into the system. You cannot expect the system to derive that thing by itself. In NARS, whatever you can teach it, you can put into it from user interface, it should be able to derive by itself, given proper experience. And also, you see everything is unified into this concept of reasoning, but this reasoning has been extended far away from the normal usage of AI. I have another paper to be presented in Monday, is talking about how to do learning as reasoning in NARS. Again, I'm going to skip that topic. Actually, many other things traditionally taken to be a separate process, in NARS, they're all implemented all together by the same process. You can call it learning, you can call it planning, you can call it perceiving, problem solving, or decision making, or many other names. They're just different aspects of the same process. Okay? That's also my belief about human thinking. Yeah, we do have different names, but it doesn't mean we have separate process in the system. Well, Do you mean your reasoning is everything? Well, of course we can use other technology, but they're all secondary. They can be used as tools, like I already said. Okay? We can plug in something as for sensation, for action, or we can call a software for a certain node. I can use all kinds of tools for the system, but they're not part of the system. Okay? They're taken to be tools in toolbox. So anyway, that's our approach. Implementation, Patrick will say more. The project has become open source for several years. Now all the source code, the documentation are not complicated or fully documented, but quite some documentation online. We have working examples, but not to the level of practical application, but as, mostly as proof of concept. Okay, just show you this thing can be done. Even though, yes, of course, there are a lot of details to be fixed. And there are many, the system show many human-like properties. We don't have the time to go through. But on the other hand, it's not a psychological model. Okay? We're not trying to simulate human mind to all the details or pass the Turing test, which I don't think is the right goal for us. Potential application. This thing is not designed as a product for any practical application. But on the other hand, there is a possibility that some of the idea can be used to be customized into some practical application, which we are currently experimenting with several corporations. Pseudo domains will typically be domains where the insufficiency of knowledge and resource cannot be ignored. You see that I'm not claiming that this NARS is a solution for all problems, not at all. If for a problem, you really have sufficient knowledge and resource, which is possible, you don't use this. Okay, this is way too complicated, unnecessary. It's only when the uncertainty, the ignorance, the confliction, and so on cannot be ignored, or traditional model cannot be used because of those reasons, then you should think about this model, or something like this. And of course, we want the task to be naturally represented as reasoning. And the tools can be used, use this compatible interface, and so on. And for the others, more details, as I said, many other things are online. And we welcome all possible participations and cooperations. That's all for me. Then it's Patrick's turn to show you our new version which was released just yesterday, just for this conference.